Masquerade employs many innovative control mechanisms both in autonomous and teleop. In autonomous, we accomplish our goals using a variety of algorithms. One of the most important of these algorithms is XY path, which allows us to input absolute points on the field and have the robot automatically travel to them. As you can see here, the robot travels to preset positions to drop the wobble goals, shoot the power shots, and line up to score the ring that it took from the starting stack. We determine the height of the starting stack, and therefore where we need to put the wobble goals, using a webcam attached to the front of our robot. Using OpenCV, we calculate the average color of the space where a stack of 4 rings would be. We then compare this value to the color value of the floor, and the larger the difference between these two values, the more rings there are. These values, as well as the configuration of the stack, are frequently updated and easily visible from the driver station, as you can see. In order to find our exact position on the field, we use small, unpowered Omni wheels, which are connected to external encoders mounted to the drivetrain. By comparing the distance traveled between all 3 Omni wheels, we can calculate how far, in what direction, and at what angle the robot has traveled. As you can see, this distance is measured in inches, and is displayed in both the X and Y directions, as if the field were a coordinate plane with the origin at the starting position of the robot. Although our mechanism wheels are moving in different directions, the odometry wheels keep their bearings. As you can see here, we've navigated to a point slightly behind the previous one, and the Y value displayed reflects this. We also use various methods to help us in teleop, including one that allows us to press a single button and shoot all 3 rings in our hopper, which allows the driver to focus on positioning and timing. Lastly, we built a teleop that we call the Servo Programmer, which allows us to test the positions of our various servos and how they interact in the context of a match. With an intuitive control scheme and graphical interface, it allows for greater consistency and precision in testing. As you can see here, I'm testing the position of our compressor and our rotator. Holding each servo's corresponding buttons or triggers on the controller slowly increases or decreases its position, displaying the exact value of the servo on the driver station, which we can then input into our code. We're also able to move 2 or more servos simultaneously, which allows us to more easily see how they interact, which is crucial for a robot as complex as ours. Thank you so much for your time, and have a wonderful day.